Now let's speak about vulnerabilities. So why are we protecting assets? Because the assets are vulnerable. And if we want to protect a specific asset, and we're going to end up implementing security measures based on the classification of the asset and the vulnerability of the asset. Like for example, for assets classified as public or unclassified, there's no need to even to identify if those are vulnerable or not, because since are publicly available, you don't even care if that information leaks out or not. For that information, you only care that information is available. So for the assets which are publicly available to the whole internet, like a claim or a description of the organization's, let's say, of the organization's role and scope, then because that's publicly available, from the attack's point of view, you only care that information is reachable and available at all times towards the user, towards the towards the users who want to know more about your company and more about your organization. But in some cases, you don't even care if like you don't even care to do a proper assessment to identify what is the likeliness that a publicly available resource can become unavailable, and then if it's going to stay unavailable for 1 hour, then is the organization good or not with that behavior. In some cases, a lot of organizations don't even go into that detail for publicly available data. Rather, they focus on the service. Because as long as the web service is functional, and that's another asset, so we have to differentiate between the web service and the data available on that web server. So if we want the data to be available, because all of the data which is there is classified as public, so we don't care who sees the data, it means that we only need to provide availability, which means we're not going to provide any countermeasures or any kind of solutions to make sure that the data is available. We're going to make sure we guard the web service. So we're gonna provide adequate technologies like redundancy to make sure that the web service runs and provides its services 99.9% of the time. But about the data stored on those on that web services, we don't provide any kind of let's say security countermeasures or security solutions in there. So it's much more productive, much more cost effective to look at who can be attacked. Because the data being stolen, we don't care because it's publicly available, but the way that data can become unavailable is by somebody attacking the web service. So there we go, you're going to focus on the web service in that case. Either way, the point is that in order to, once you have identified and classified your assets, which means you know what do you have to protect, which assets have to be protected, then you have to identify, based on those asset types, what are the vulnerabilities that those assets are being exposed to. And that is going to be likewise classified into many, let's say, categories. It can be policy flows, which is going to be like a security policy flow, which, for example, let's say that in order to change your Windows password, so let's say that your company's Windows password policy states that the password has to be minimum 10 characters with special characters with both capital and small letters, those kind of things. Okay, but then, for example, the company security, but the system doesn't enforce that. So like the system allows you to put any password you want, like you can put a simple password as CISCO, for example, but then the password policy, which is dictated by the company, states you have to put passwords which are minimum 10 characters, special characters involved as well, and both small and capitals in there. So that's the security policy for putting passwords, for creating passwords, but then it's not enforced by let's say specific technologies. So that can be seen as a policy flaw. Or for example, maybe the security policy states how to create passwords to begin with, but a security policy doesn't state how to change your password, which means that the user can end up, when he's going to change his password, can end up actually using a simple password at Cisco, because the document which guides the user how to change its password allows the user to put any kind of password. So then the user is going to choose up a simple password. So that's like a policy flaw. Well, we can have a firewall policy flaw, for example, where you put firewalls in the network, and then because of the order of operation within the firewall, then a policy flaw showed up, and more access to the network was given than otherwise was required to begin with. We have design flaws, which, for example, that could one example of design flaw. We can speak about hardware design flaws, or software design flaws, or network design flaws. So it's different variations of design flaws. Like a hardware design flaw could be, for example, that if somebody takes a specific action on a hardware or physical device, then an unexpected behavior is going to happen, right? That's going to be a hardware design flaw. A software design flaw is like a bug within the code. Not a bug within the code, but is due to let's say bad programming, which means that the developer who programmed that specific software didn't follow up on a best practices or on a secure way of writing code down, and it ended up with a software design flaw. Or network design flaw is where you design the network without seeing everything which is attached to the network, and you may fail to oversee that in a specific region of the network you have some assets which should have been protected or safeguarded against specific types of attacks. Protocol built-in flaws, like each protocol has a lot of flaws. Like for example, HTTP has built-in flaws, SSL has built-in flaws, TLS has built-in flaws, which of course they were because of bad programming or failure to oversee how that protocol is going to be used in the end. But it's actually another kind of flaw. Software flaws we're speaking about us quite a lot could be in the format of bugs in general, and I hope everybody is aware of what a bug is. A software bug is when the system is configured to behave in a certain way, but then it ends up behaving in a different way. That's a software flaw or a bug. Misconfiguration flaws, like the example I gave you with the firewall, where you should, for example, if you look at the network in here, let's say that you want users to be able to go this side, again being the LAN. So in here you have the LAN side, and in here you have the internet side. Internet. Then you may want your security engineers to configure the firewall in such a way that inbound access from the internet is available only for a destination of the server, let's say 12, 12, 12, 12. On TCP port 443. So that's the only kind of traffic you would allow people from the internet to send in your network. So that should be your firewall rules security policy from the internet. But accidentally, because for example, one common use case which happens in real life deployments, because the engineer that has configured the firewall is not exactly aware of the entire architecture of that firewall. So how does that firewall work? Because although we have a lot of vendors that have different kinds of firewalls, and pretty much all of them tend to do the same thing, they follow up on the same results, the implementation is different. So then as an engineer was used to configure a Palo Alto firewall in a specific way to provide this kind of access, but then he moves around to a Cisco firewall to provide the same kind of access because he's not aware yet with the architecture of that firewall, then he may accidentally end up to allow more access than actually required because he's not aware how the firewall works end to end. So he knows what he has to do. He knows he has to allow that specific traffic only, but is not aware how to actually make sure that he's going to implement that properly on the firewall because he's not yet knowledgeable enough with the firewall operating system and architecture as designed by the vendor. Then this is actually very common. This is actually a very common mistake when engineers move on from vendor A to vendor B on the same security product, but it's going to be different visions of the vendors, which ends up in different implementations and behaviors to achieve the same thing. And then is human flaws, which are probably the most difficult ones to defend against. We're going to see, based on a couple of types of attacks, what does a human flaw mean. Basically, it is the option or the attack, the time when the attacker manipulates people in order to gain specific access to specific information or just to obtain immediate, let's say, results. We're going to speak about it in a couple of seconds. So the human flaws are actually the most difficult ones to protect against, and we're going to see in a couple. The other ones, like even the design flaws or even the protocol built-in flaws, as soon as you're aware of those, it's faster and simpler to protect, to put in security solutions to defend against those flaws, as opposed to putting in some security measures to defend against human flaws, human errors. There are a couple of publicly available list of vulnerabilities, both classification and general system vulnerability management on those two websites. Now, of course, those are only general guidelines. They have very, very good, let's say, materials on those two websites. So again, it's both for vulnerability classification and also for a general approach of how should you deal with the vulnerability management within a organization. Okay, let's see if you have any questions before we continue. Okay, not really. It's expected because this is theory. But even if as I was saying, if today's class is mostly theory, whatever is unclear or whatever let's say it's quite new to you or you have not understood it properly from my explanations, you can go ahead and put questions in there.